Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to study ICSE Class 10 Maths Chapter 22 Heights and Distances. We will understand the concepts with examples and solve questions from Exercise 22A and Exercise 22B. Are you ready? Yes, let's start. Heights and distances. We have studied the chapter trigonometry. You all remember, right? In trigonometry, we have studied sine theta, cos theta, tan theta, then the reciprocal of these angles. After that, we have studied the values of sine 0, sine 30, sine 45, sine 60, sine 90, etc. But where do we really apply this? Is there any application to this trigonometry? Yes, here comes the application of trigonometry, heights and distances. We can easily measure our length, right? Using a measuring tab, you can measure the length of a person or height of a person. Okay, you can measure the length of this board, the breadth or width of this board using a measuring tab. Do you think it is that easy to measure the height of the Eiffel Tower? No, right? We cannot measure using a measuring tab. So, in that case, what can be done? Here we apply the trigonometry and find the height of the Eiffel Tower. Not just Eiffel Tower, any tall buildings or any trees, we can measure their height using trigonometry. Okay, today we will understand how to use trigonometry to find the height of tall buildings or the height of trees, etc. Angles of elevation and depression. This is a basic thing that we need today. For example, take this case. Here we have a person who is standing on a building. Imagine that. Okay, here we can find an aeroplane in the sky. If this person want to look at this aeroplane, what he will have to do? He will have to raise his head, okay, by certain angle. Okay, the line, this straight line, if I am standing here, this is a straight line of sight. Okay, but I cannot see an object which is above this line or below this line. To see an object which is above or below this line, I will have to raise my head or bow downwards. Yes, so by what angle he will have to shift his eyesight in order to see the object is called the angle of elevation. He is moving his head upward by an angle. Okay, so this angle from the horizontal line is called the angle of elevation. Now, angle of depression. This person is on a building. We are imagining this person is on a building and he want to see a dog on the ground. What he will have to do? If he look at straight, he cannot find this dog. What he will have to do? He will have to bend downwards, bend his head downward in order to see the dog. In that case, the angle made with the horizontal is called the angle of depression. Just take this case. If the pen is held like this is my horizontal line. I can find the pen here. I can see it clearly. Now what I am doing? I am holding the pen upwards. What happens? If I am looking in this case, I cannot find the pen, right? To find the pen, what I have to do? I will have to raise my head by a certain angle and this angle is known as the angle of elevation. Now, if the same pen is taken to this position, I am holding the pen down. Okay, this is my horizontal line. To see the pen, what will have to do? I will have to bend downwards. So, I am bending. The angle that I made is called the angle of depression. Okay, and the straight line from the object to the person is called the line of sight. Line of sight. Okay, got the basic things. What is a line of sight? Line of sight is a straight line from our eye to the object. Then angle of elevation, an angle that is formed with the horizontal line if the line of sight is upward. Here line of sight is upward, then the angle is angle of elevation. Next, angle of depression, an angle that is formed with the horizontal line if the line of sight is downwards. Here the line of sight is downward. This is the line of sight. Okay, when the line of sight is downward, we call it angle of depression. Now take an example. This is a ground. Okay, here we have a tall building A, B. A person is standing on the ground at a position C. In order to see an object that is on the top of this building, what he will have to do? He will have to raise his eye by an angle. Okay, then this angle is angle of elevation or angle of depression. Here we have CB will be the horizontal line. Okay, CB will be the horizontal line. From the horizontal line, he will have to raise upwards, which he is making an angle upwards, which means this is the angle of elevation. Okay, we have angle of elevation here. Now take another case. A person who is standing at this point on the top of the building and want to find an object that is placed at the position C. In that case, we'll be having angle of elevation or angle of depression. So here, this line will be the horizontal line for a person. If you are taking a person standing at position A, at the point A, here this straight line is his horizontal line. Yes, here he has this horizontal line. What will he do in order to find an object that is placed at position C? He will have to bend downwards, makes an angle. Okay, this angle made will be the angle of depression because it is with the horizontal line and the line of sight is downward. Here the line of sight is upward, here the line of sight is downward. Okay, now when you consider both these horizontal lines, this is the ground and this is the horizontal line which respect to A. We can see that these two lines are parallel. Okay, for parallel lines, AC will be a transversal. When for parallel lines at transversal cuts, we know that the corresponding angles are equal, alternate interior angles are equal. Yes, here this angle and this angle are alternate interior angles. Therefore, they will be equal. Okay, so understand this. For an object which is placed at C, when the object is viewed from A, the angle of depression will be equal to the object placed at point A and viewed by a person from C, the angle of elevation made. Okay, the angle of elevation here and the angle of depression here will be equal. Clear? If this is 30 degree, what is this value? Angle of depression will also be equal to 30 degree. Okay, now take a case. We know the height of building. Okay, let us take the height of building equal to some 10 meters. Okay, height of building is 10 meters. We have to find the distance at which the person is from the building. From the building he has moved at distance and reached the point C. We have to find this distance. Okay, let us now take this distance as some x. We have studied trigonometry. We know that sine theta is equal to opposite side by hypotenuse. Okay, here opposite side, our angle is 30 degree, opposite side is this 10 meter, AB 10 meter. Okay, hypotenuse is this. What we need is the adjacent side. Here x is the adjacent side. So we cannot take sine. Sine cannot be used. What about cos? We have cos theta is equal to adjacent side divided by hypotenuse. Okay, here adjacent side is there, but we don't know the value of hypotenuse. So we cannot use this. Next, when you take tan theta is equal to opposite side divided by adjacent side. This can be used. Opposite side value we know, that is 10 meter, height of building. Okay, and adjacent side is what we have to find, that is x. Tan theta, tan 30 degree value also we know. Yes, tan 30 degree is equal to 10 divided by x. What is the value of tan 30 degree? Tan 30 degree is equal to 1 by root 3. So you should remember these values. 1 by root 3 is equal to 10 divided by x, which implies x is equal to, cross multiplying, x is equal to 10 root 3. Okay, what is the value of root 3? Root 3 is 1.732. 10 into 1.732, that is 17.32 meters. Okay, 17.32 meters is the distance at which the person is standing from the building. Okay, Another case, if you know this distance, the distance at which the person is from the building, you can find the height of the building. Just the opposite thing. Here, we'll be putting the height of building as x and put the value of adjacent side. We'll be getting the answer. We can determine the height of building. Understood? This is the basic things we need to know. You should know either to use sine, cos or tan. If we have opposite and adjacent to be considered, then tan. If we have adjacent and hypotenuse, then cos. If it is opposite and hypotenuse, then sine. Okay? By taking some example, we'll understand it further. Here we have the first example. The length of the shadow of a vertical tower is √3 times its height. Find the angle of elevation of the sun. Okay? Here we have sun at some position. This is our vertical tower. Let us name it as AB. Okay? Vertical tower AB. Then, what is given? Length of the shadow of a vertical tower is √3 times its height. Okay? If we are taking height of the tower as x, height of tower we are taking as x, the length of shadow will be √3 times x. Okay? Shadow will be on the ground. Let us take a point C. This is the length of shadow and it is equal to √3 times x. Okay, we have to find the angle of elevation of the sun. Angle of elevation from this point C. And now draw a straight line. And this angle is the angle of elevation. Okay, we have to find this angle. Let us represent it as theta. Let angle of elevation be theta. Okay. When angle of elevation is theta. Here, considering theta and this is the right triangle, right angled at B. We have opposite side and adjacent side. Opposite sides and adjacent side. In that case, we will have to consider tan. Tan theta will be equal to opposite side divided by adjacent side. Tan theta will be equal to x divided by √3x. Okay, x and x gets cancelled. Then we have tan theta is equal to 1 by √3. When do we get 1 by √3? What is the value of theta when tan theta is equal to 1 by √3? 1 by √3 is at 30 degree. Correct. So, tan theta will be equal to tan of 30 degree. Then what is theta? Theta is 30 degree. So, the angle of elevation to the sun will be equal to 30 degrees. Clear? Understood? Second example, from a point on the ground, the angle of elevation of the top of a vertical tower is found to be such that its tangent is 3 by 5. On walking 50 meters towards the tower, the tangent of the new angle of elevation of the top of the tower is found to be 4 by 5. Okay. Find the height of the tower. Let us consider a tower A, B. This is ground. Okay. From a point on the ground, the angle of elevation of the top of the vertical tower is found to be such that its tangent is 3 by 5. From this point, let us take a point C, making an angle of elevation to the top of the vertical tower. Let us take the angle as some alpha. Okay. Now, from this point C, what happens? On walking 50 meters towards the tower, he reaches a point, new point D. From there, let the angle of elevation be some beta. Okay. From this point, the angle of elevation is beta. We have to find the height of tower. Now, let us take the height of tower as h. This distance is 50 meters. Okay. Let us take the distance from the tower to the second point as some x meters. Okay. We take this as some x meters. Okay. What is given? Given that tan of alpha is equal to 3 by 5. What is alpha? Alpha is the angle of elevation from the first point to the top of the vertical tower. Okay. Also, it is given that tan beta is equal to 4 divided by 5. Okay. Now, consider the first triangle ACB. Here, this angle will be equal to 90 degrees. So, we have two right triangles. First right triangle is the bigger one, ACB, and the second is ADB. Okay. Consider triangle ACB. In triangle ACB, we have tan of alpha is equal to tan alpha opposite by adjacent. Here opposite is AB divided by adjacent CB. What is AB? AB we have taken as h, height of tower. Then CB. CB will be equal to 50 plus x. 50 plus x. Okay. Tan alpha value we know, which is 3 by 5. So, 3 by 5 is equal to h divided by 50 plus x. Now, cross multiplying, we get 3 into 50 plus x is equal to 5 into h. Okay, that is 3 into 50, 150 plus 3 into x, 3x is equal to 5h. We take this as the first equation. Equation 1. Now, consider the second triangle ADB. Consider triangle ADB. In triangle ADB, we have angle beta. Tan beta will be equal to opposite by adjacent. Here opposite is AB divided by adjacent DB. Okay, AB is taken h and dB is equal to x. What is tan beta? Tan beta is equal to 4 by 5. Therefore, 4 by 5 is equal to h divided by x. On crossing, we get 4x is equal to 5h. This is our second equation. Now, comparing 1 and 2. Comparing equation 1 and 2. Okay, when you check both these equations, RHS here we have 5h and here also it is 5h, which means when right hand sides are equal, left hand side should also be equal. Therefore, 150 plus 3x is equal to 4x. When you compare first and second equation, we get 150 plus 3x is equal to 4x. Now, taking all the variable containing terms to one side, shifting this 3x to the right hand side, we get 150 is equal to 4x minus 3x, or x is equal to 150. 4x minus 3x is x and x will be equal to 150 meters. What is x? X is the distance of the second point from the tower. What we have to find? We have to find h. How to find h now? Considering this equation, 4x is equal to 5h. We'll be having h is equal to 4x divided by 5. Okay, from second equation, we have 4x divided by 5 is equal to h. Put the value of x. H will be equal to 4 into 150 divided by 5. 4 into 150, that is 600 by 5, we get 120 meters. So, the height of the tower will be equal to 120 meters. Okay, 120 meters. Clear? So, this is how you can solve this problem. Now, let us solve problems from exercise 22A. First question, question 1 of exercise 22A. The height of a tree is √3 times the length of its shadow. Find the angle of elevation of the sun. Here, we have a tree. Okay, and this is the shadow of the tree. Let us take AB as the height of tree. Here we have shadow. This is up to C. Okay, CB is the shadow of the tree. It is given that height of tree is √3 times the length of its shadow. If we take the length of shadow as x, then the height of the tree will be equal to root 3 times x. Okay, and this angle we are taking as theta will be the angle of elevation. Okay, let length of shadow be equal to x meters. Okay, if length of shadow is x meters, then the height of tree will be equal to root 3 times x meters. Okay, now we are taking theta is the angle of elevation. If theta is the angle of elevation, then taking tan of theta. Tan of theta. Why tan is taken? Here we have to find x value. Okay, what is x? X belongs to both the opposite side and the adjacent side. So we don't need hypotenuse. And using tangent, we will be using opposite and adjacent. Tangent, tan of theta will be equal to opposite side divided by adjacent side. Here opposite side is AB divided by BC. Okay, put the value tan theta. Tan theta is equal to AB is root 3x divided by BC is x. Cancelling x and x, we get tan theta is equal to root 3. Where do we get root 3? At what angle of tangent we get root 3? It is at tan 60 degree. Okay, so tan theta is equal to tan 60 degree and then theta will be equal to 60 degree. Okay, the required angle of elevation to the sun is equal to 60 degree. Clear? Second problem, question 3 of exercise 22A. A ladder is placed along a wall such that its upper end is resting against a vertical wall. The foot of the ladder is 2.4 meter from the wall and the ladder is making an angle of 68 degree with the ground. Find the height up to which the ladder reaches. Here, this is your vertical wall, okay, and the ladder is placed in such a way that the ladder's upper end is resting on the wall, okay, and the base is at a distance of 2.4 meter from the wall. Here, the angle of elevation, that is this angle the ladder makes from the ground to the vertical wall is equal to 68 degree. Okay, let us take this height as AB. And C is the point where the base of ladder comes. What we have to find? We have to find the height up to which the ladder reaches. The height up to which ladder reaches is the height AB. Okay. Here, let us take this height as some h meters. Let the height up to which ladder reaches be h meter. Okay, let it be h meter. Now, what we have, if we are taking the tangent opposite, we have to find an adjacent is given. Therefore, tangent of the angle. Tan 68 degree will be equal to opposite AB divided by adjacent BC. Okay, opposite is h. Therefore, tan 68 degree is equal to h divided by 2.4. Now, how to find tan 68 degree? We have studied while taking the chapter trigonometry how to measure these type of angle. We know the values of tan 0, tan 30, tan 45, tan 60 and tan 90. Apart from that, when you get other angles, how to find? We will be using the natural sine, natural cos, natural tangent. So, in the Selina publications, page number 454, you have natural tangents, 454 and 455. So, we need 68 degree. Find the degree measure 68 degree. If it is 68 degree, it means 68 degree will be equal to 68 degree 0 minutes. Okay, just consider the value which is given in the second column for 68 degree. 68 degree 0 minutes will be equal to 2.4751. Okay, that is 2.4751. Then we'll be having 2.4751 is equal to h divided by 2.4. Okay, then what is h? H will be 2.4 into 2.4751 and the final answer will be 5.94 meters. Okay, when multiplying 2.4 into 2.4751, you will be getting 5.94 meters. So, the required height at which the ladder reaches from that is on the wall will be equal to 5.94 meters. Clear? So, in this case, we have used the natural tangents to find the value of tan 68 degrees. Next, problem number 3, question 5 of exercise 22A. A kite is attached to a string. Find the length of the string when the height of the kite is 60 meter and the string makes an angle 30 degree with the ground. So, you all might have played with kites. Yes? So, while flying kites, you know that the kite, when you cannot hold it in the same vertical line, how the kite will be? Here, if you are standing at this position, then at some angle, the kite will be flying. Okay, here we have the kite. It is neither vertical or horizontal. It will be at an angle, some angle from the ground. Okay, so this is the ground and it is given that this kite is flying at a height of 60 meter from ground. Okay, and the angle made is 30 degree with the ground. The string of the kite makes an angle 30 degree. Okay, now the position of kite we can take as A, ground point B, and where the person is standing is taken as C. Okay, we have to find the length of string. Length of string means it is this length. We'll take it as some h meters. Let length of string be h meters. Okay. Now, here h meters, this AC is the hypotenuse of right triangle ABC. So, is there any use taking tangent? Tangent is when opposite and adjacent is considered. But here, we have to find the hypotenuse. Opposite side should be included. Opposite and hypotenuse. Which trigonometric function to use? Sine, correct. So, we will be using sine of the angle. Sine theta is equal to opposite side divided by hypotenuse. Okay, here the angle is 30 degree. Therefore, sine 30 degree is equal to opposite AB divided by hypotenuse AC. Sine 30 degree is equal to AB. AB is given 60 meters and the hypotenuse is h. What is the value of sine 30 degree? Sine 30 degree is equal to 1 by 2. 1 by 2 is equal to 60 divided by h. Crossing, we get h is equal to 60 into 2 and h is equal to 120 meters. So, the required length of string is equal to 120 meters. Very simple, right? So, you have to remember in this case using tangent we won't be able to find the answer. If you are using tangent, what you will be getting? You will be getting this distance. After getting this distance, you will be having the height and the base and then we can find hypotenuse. So, don't do that. Here, by using the sine as a trigonometric function to be considered, we can find the height h. Okay. Let's move on to the next problem. Problem 4, question 9 of exercise 22A. At a particular time, when the sun's altitude is 30 degree, the length of the shadow of a vertical tower is 45 meter. Calculate the height of the tower. This is the first part. And the second part, we have to calculate the length of the shadow of the same tower when the sun's altitude is 45 degree and 60 degree. Sun's altitude is changing. When it becomes 45 degree and 60 degree, we have to find the length of shadow. Okay. First, let us find the height of the tower. How to find the height of tower? Here what is given? Sun's altitude. So, let us take AB as the height of tower. This is the required tower, AB. The length of the shadow of vertical tower. The length of shadow. Shadow is on the ground and this length is 45 meter. Okay. When the angle of sun's altitude is 30 degree. To find the height of tower, let us take this as H. Let H be the height of tower. Okay. Here H is the opposite side and 45 meters is the adjacent side, which means we will have to consider tangent. Okay. Tan theta is equal to opposite divided by adjacent. Here tan 30 degree is equal to H divided by adjacent is 45. Okay, what is tan 30 degree? Tan 30 degree is equal to 1 by root 3 is equal to H by 45. On crossing, we will be getting H is equal to 45 divided by root 3. Okay, in denominator we are having root. So, what we do is multiply numerator and denominator with root 3. You will be getting H is equal to 45 root 3 divided by root 3 into root 3 is 3. 3 into 15 is 45. So, 15 root 3. Okay. We know the value of root 3. 15 into 1.732. So, the final answer you will be getting on multiplying 15 into 1.732. You will be getting 25.98 meters. Okay. 25.98 meters is the height of the tower. The vertical tower is of height 25.98 meters. Now, let's move on to the second part. The length of the shadow of the same tower when the sun's altitude is 45 degree and 60 degree. Here, the height of tower we determine that is 25.98 meters. Okay. For calculation to be easy, we can keep it as 15 root 3. Okay. Now, when the angle is theta is equal to 45 degree, we have to find the length of shadow. Here, we will be taking the length of shadow as some x. Okay. Angle is 45 degree. When angle is 45 degree, we will be having tan 45 degree is equal to opposite AB divided by BC, and that is 15 root 3 divided by x. 15 root 3 divided by x. Okay. What is the value of tan 45 degree? Tan 45 degree is equal to 1. Okay. 1 is equal to 15 root 3 divided by x, which implies x will be equal to 15 root 3. X is equal to 15 root 3. That is, when the angle of elevation is 45 degree, the height of the shadow and the height of the tower will be equal. 15 root 3 meters, or you can give the value, that is 25.98 meters. Now, when the angle becomes 60 degree, AB is the height of tower, which is 15 root 3. Here we have a point D. Consider the angle of elevation is 60 degree. Okay. Then tan 60 degree will be equal to, we are taking this distance as x, AB divided by BD, and that is AB, opposite side, 15 root 3 divided by BD is taken as x. What is tan 60 degree? Tan 60 degree is equal to root 3. So root 3 is equal to 15 root 3 divided by x. To get x, cross multiplying, we get 15 root 3 divided by root 3. So since we have kept this root 3 as it is, we can cancel them. Then the answer is 15 meters. Okay, when the angle is 45 degree, we will be getting the length of the shadow equal to 25.98 meters, and when the angle is 60 degree, we will be getting the length of shadow equal to 15 meters. So what is happening? Is the length of the shadow increasing or decreasing with angle? First, the angle was 30 degree, then the angle became 45 degree, then the angle became 60 degree. That is, angle is increasing. Here the length of shadow was 45 meters. Here it reduced to 25.98 meters, and when it becomes 60 degree, it reduced to 15 meters. That is, when the angle of elevation is increasing, the length of shadow is decreasing. Okay, clear? Problem 5, question 12 of exercise 22A. A man stands 9 meters away from a flagpole. He observes that angle of elevation of the top of the pole is 28 degree and the angle of depression of the pole is 13 degree. Calculate the height of the pole. So this is a flagpole AB. Okay, a man is standing here. Let us take the base as Q and the top as P. Now what is given? Here is where we have the eyes of the person. Angle of elevation. Now this is the horizontal line. Angle of elevation to the top of the flagpole is given 28 degrees. Okay, and the angle of depression, that is to the base of the flagpole, will be 13 degrees, which is given in the question. What we have to find? We have to find the height of the pole, this total height. Let us take this point as some C. Okay. We have to find what AB is. What else is given? It is given that a man stands 9 meters away from a flagpole, which means this distance is 9 meters. Here we have flagpole and the person is at 9 meter distance from the flagpole. If this is 9 meters, a line that is parallel to this will also be equal to 9 meters. Okay, PC will also be equal to 9 meters. We are having AB is equal to AC plus BC. Okay, we can separately find what AC and BC are. To get AC, consider triangle APC. AC is a side of triangle APC. Okay, now we know this length, that is the adjacent side to the angle 28 degree, and AC is opposite, which means we have to consider opposite and adjacent, therefore tangent. Taking the tangent of 28 degree will be equal to AC divided by PC. Okay, PC is 9. Therefore, we will be having AC is equal to PC into tan 28 degree, that is 9 into tan 28 degrees. AC is 9 into tan 28 degrees. Now, to find BC, we have to consider triangle BPC. Consider triangle BPC. In triangle BPC again, when you consider this angle 13 degree, PC is adjacent side and BC is the opposite side. Yes. Therefore, we will be having tan 13 degree is equal to BC, opposite divided by adjacent PC. Okay, we need BC. Therefore, BC will be equal to PC into tan 13 degree. That is BC equal to, PC is 9 meters, 9 into tan 13 degree. Okay, so we have AC and BC. Tan 28 degree and tan 13 degree can be determined using the natural tangents. We have AB is equal to AC plus BC. Put the values. AB is equal to AC 9 into tan 28 degree plus 9 into tan 13 degree. Okay, 9 is common, taking out 9, tan 28 degree plus tan 13 degree. Okay, now take the natural tangents, find the value of tan 28 degree. Tan 28 degree is 0.5317, 28 degree 0 minutes. Okay, so we'll be just rounding it. 9 into 0.532. 17 can be rounded to 532 plus tan 13 degree. Tan 13 degree 0 minutes, you will be getting 0.2309, that can be round 0.231, approximately 0.231. Okay, equal to 9 into, on adding this we will be getting 0.763. 9 into 0.763 is equal to 6.867 meters. Okay, 6.867 meters is AB. That is the total height of the flagpole. Height of flagpole is equal to 6.867 meters. Understood? So this is your final answer. Now we'll be solving questions from exercise 22B. Here we have the problem 6, question 2 of exercise 22B. Find the height of a tree when it is found that on walking away from it 20 meter in a horizontal line through its base, the elevation of its top changes from 60 degree to 30 degree. So here we have a tree. Let the height, we take it as AB. Okay, this is the tree. Now a person is standing at some x distance. Let's consider x distance at a point C. Then the angle of elevation was equal to 60 degrees. What he did is he moved 20 meter away from there. Okay, 20 meter away and reached a point D. So this is 20 meter. Then when he looked to the top of the tree, the angle of elevation is 30 degree. Okay, we have to find the height of the tree. Let us take the height as h. Let height of tree be h meters. Okay, and initial position of the person is x meter from the base of tree. This is what we are considering, base of tree. From the base of tree, the person is at x meter distance. Okay. Now, here when you consider this triangle ACB, in triangle ACB, h is the opposite side and x is the adjacent side. When you take the second triangle ADB, h is the opposite side and 20 plus x is the adjacent side. Okay, using which we can find the height. First consider triangle ACB. Will be having tan of 60 degree is equal to h divided by x. Okay, that is AB divided by BC, h divided by x. Tan 60 degree is equal to h divided by x. What is tan 60 degree? Tan 60 degree is equal to root 3. Root 3 is equal to h by x. Okay, then we can write h is equal to root 3 times x. H is root 3 times x. Then, when you consider triangle ADB, in triangle ADB, we will be having tan of 30 degree. Tan 30 degree is equal to opposite by adjacent. Opposite is h divided by adjacent 20 plus x. What is tan 30 degree? Tan 30 degree is equal to 1 by root 3. 1 by root 3 is equal to h divided by 20 plus x. Okay. When cross multiplying, we will be getting 20 plus x is equal to root 3 times h. Okay. Now what we are going to do is, we have from the first triangle h is equal to root 3 into x. Okay. Now in this position, we are going to put the value of h. This is our equation 1 and this is equation 2. Substituting h is equal to root 3x in equation 2, we get 20 plus x is equal to root 3 into root 3x. 20 plus x is equal to root 3 into root 3 is 3. 3x, taking this x to the opposite side, we get 20 is equal to 3x minus x, or 3x minus x is 2x. 2x is equal to 20. If 2x is equal to 20, then what is x? X will be equal to 20 by 2, that is 10 meters. So we got this distance 10 meters. What we have to find is the height of tree. What is the relation? Here we have h is equal to root 3 times x. Okay. H is equal to root 3 times x. That is root 3 into 10. Root 3 is equal to 1.732 into 10, that is 17.32 meters. Therefore, the height of the tree is equal to 17.32 meters. Okay. Next, problem 7, question 5 of exercise 22B. Two pillars of equal height stand on either side of a roadway which is 150 meter wide. At a point in the roadway between the pillars, the elevations of the tops of the pillars are 60 degree and 30 degree. Find the height of the pillars and the position of the point. Okay. Here, this is a roadway. We have two pillars of equal heights. Okay. Let us take this as AB and this as CD. Now, what is given? The total width is 150 meter. This is 150 meters. Okay. Now, when you consider a point on the roadway, some point on the roadway, from there, the angle of elevation to the top of the first pillar is equal to 60 degree, and that to the second pillar is 30 degrees. Okay, we have to find the height of the pillars and the distance of the point from the pillars. Okay, here let us take the distance of the point from the pillar as some x. Okay, we are taking this as x. This distance is taken as x. If this distance is x, then this distance will be equal to 150 minus x. Now here we have a point E. From this point E, we have the elevation 60 degree and 30 degree to C and A, which are the top of the pillars. Okay, this distance is taken, DE is taken as x. Okay, distance of E from the first pillar is taken as x. Then its distance from the second pillar will be equal to 150 minus x. First, let us find what is the height of pillars. Let h be the height of pillar. Okay, both the pillars are of equal height. For that, to get the height, we'll be considering two different triangles. Let us take the first triangle. Consider triangle CDE. This triangle CDE. Okay, we have taken H as the height of pillars. H is the opposite and adjacent is X. Okay, taking tan of the angle, tan 60 degree will be equal to CD divided by DE, and that is H divided by X. What is tan 60 degree? Tan 60 degree is equal to root 3. Root 3 is H divided by X, from which we will be having H is equal to root 3 times X. Okay, H is equal to root 3 times X is our first equation. Now consider the second triangle. Consider triangle ABE. Here we have angle 30 degree. Tan of 30 degree will be equal to opposite AB divided by adjacent side BE. And that is H divided by, here we have X, therefore this is 150 minus X. 150 minus X. Tan 30 degree, what is the value? 1 by root 3. 1 by root 3 is equal to H divided by 150 minus X. Cross multiplying, we get 150 minus X into root 3 H. Okay, this we are taking as equation 2. Now putting the value of H from equation 1 in equation 2, we get 150 minus X is equal to root 3 into H value is root 3x. Root 3x. Okay, 150 minus X is equal to root 3 into root 3 is 3x. Now taking this minus X to the opposite side becomes plus X. 150 is equal to 3x plus X, which means 150 is equal to 4x, implies X is equal to 150 divided by 4. What is the value? We'll be getting 37.5 meter. Okay, so 37.5 meter is the distance of the point from the first pillar. That is the X value. We need the height. We have height is equal to, H is equal to root 3x. We have X is 37.5. Therefore, H is equal to root 3 into 37.5. What is root 3? 1.732 into 37.5. Okay. On multiplying, we will be getting 64.95 meters. Therefore, height of pillar is equal to 64.95 meters. If the height of pillar is 64.95 meters, the second part of the question is we have to find the position of the point. So, the point E is at X distance from the first pillar. Okay, that is the distance of point from the first pillar is equal to 37.5 meters. And if you want to find the distance from the second pillar, what will be the distance? It is 150 minus X. Distance from second pillar will be equal to 150 minus 37.5. Subtracting, will be getting 112.5 meters. Okay, 112.5 meters. Clear? Problem number 8, question 10 of exercise 22B. A man in a boat rowing away from a lighthouse 150 meter high takes 2 minutes to change the angle of elevation of the top of the lighthouse from 60 degrees to 45 degrees. Find the speed of the boat. So here we have a lighthouse AB of height 150 meters. Okay, this is the initial position. From the initial position, the angle of elevation is 60 degree. Let us take the initial position as C, which is at X distance from the lighthouse. In 2 minutes, what happens? The position changes to D, and let us take this total decision. Let us take this total distance as Y. Okay, this total distance is Y. Here the angle of elevation is 45 degree. What we have to find? We have to find the speed of boat. This is somewhat a different question, right? To get the speed, we should know the time taken and the distance travelled. We have studied speed is equal to distance by time. Time is given 2 minutes. Okay, what about distance? This is the initial position and D is the final position. So, this distance will be the distance travelled. Total Y minus this part X will give us the distance travelled. Okay, once you get the distance travelled and using time, we can find what the speed is. Here, let X be the distance of initial position from lighthouse, and Y be the final position distance from lighthouse. Okay. Now consider the triangle separately. First, consider the triangle. Consider triangle ADB, the bigger one. We are considering the triangle ADB. Here 150 meters is the opposite side and we have the adjacent, which is Y. Angle is given 45 degree. So using tan of 45 degree, tan of 45 degree equal to opposite AB divided by adjacent DB. That is 150 divided by Y. Okay, tan 45 degree is equal to 150 divided by Y. What is tan 45 degree? 1. 1 is equal to 150 divided by Y, which implies Y is equal to 150 meters. Okay, so this total distance is 150 meters. Next, we have to consider the second triangle. Consider triangle ACB. Here we have tan of 60 degree, opposite by adjacent. Opposite is AB and adjacent is CB. AB divided by CB. Okay, tan 60 degree is root 3 equal to AB 150 divided by CB is X, which means X will be equal to 150 divided by root 3. Okay, in the denominator we have root. Therefore, multiplying numerator and denominator with root 3, we get 150 root 3 divided by root 3 into root 3 is 3, which is equal to 50 root 3. Okay, 50 root 3. X is 50 root 3 and Y is equal to 150 meters. We have distance travelled. Distance travelled equal to Y minus X. Y is the final position distance and the distance from the initial position to the lighthouse is equal to X. Therefore, the distance travelled will be equal to Y minus X. Y is 150 meter. 150 minus 50 root 3. Okay, taking common, 50 can be taken out. Then we'll be having 3 minus root 3 meters. So, this is the distance travelled. 50 into 3 minus root 3 meters. Okay. Next, we need the time taken. Time taken is given 2 minutes. When distance is in meters, time should be in seconds. 2 minutes. We have 1 minute is equal to 60 seconds. Therefore, 2 minute will be equal to 2 into 60 seconds. That is 120 seconds. Okay. So 2 minutes is equal to 120 seconds. The total time taken is 120 seconds. Therefore, we'll be having speed. Speed is equal to distance divided by time. Here the distance is 50 into 3 minus root 3 divided by time taken 120 seconds. When you divide this, you will be getting final answer 0.52. What is the unit? Distance is in meter and time is in seconds. 0.52 meter per second. Okay. Speed. Speed with which the man is rowing boat is equal to 0.52 meter per second. Clear? Problem 9, question 15 of 22B. From the top of a hill, the angles of depression of two consecutive kilometer stones due east are found to be 30 degree and 45 degree respectively. Find the distance of the two stones from the foot of the hill. Okay, here we have a hill AB. Okay, this is the horizontal line. Here we have the ground. From A, there are two stones which are viewed, which are at 1 kilometer distance from each other. Let the position of first stone we take as C and the position of second stone as D. Okay. Now, here the angle of depression to the two stones from A are given 45 degree and 30 degree. So, this is 30 degree. To the second stone it is 30 degree and to the first stone it is 45 degree. Okay. Now, this angle of depression will be equal to angle of elevation from here. Okay. If you are standing at D and looking at this point A, the angle of elevation formed will be equal to this angle of depression, which means here we will be having 30 degree. Similarly, when you are at position C and looking at this point A, the angle will be the angle of elevation and will be equal to this angle of depression 45 degrees. This angle will be 45 degrees. What we have to find? We have to find distance of the two stones from the foot of hill. Foot of hill is B. We have to find this distance CB and this distance DB. Okay. Let us take this CB as X. Distance CB as X. Then what is DB? DB will be equal to X plus 1 kilometer. Let first stone be at X meter distance from foot of hill. Okay. Therefore, we will be having distance of second stone from foot of hill equal to X plus 1 kilometers. Okay. This is kilometers, X kilometer and X plus 1 kilometers. Now what we will be doing? We will be considering two separate triangles. Here let the height of the hill be H. Let H be the height of hill. These are our considerations. First thing what we need is considering the triangle ADB. Consider triangle ADB. In triangle ADB, here we have 30 degree angle, opposite side, adjacent side. We will be having tan 30 degree is equal to opposite AB divided by adjacent DB. Okay, tan 30 degree, what is the value? 1 by root 3. 1 by root 3 is equal to AB is H divided by DB is X plus 1. Or will be having x plus 1 is equal to root 3 times h on cross multiplying. Okay. This is taken as the first equation. Now consider the second triangle. Consider triangle ACB. In triangle ACB, the angle is 45 degree. Tan 45 degree is equal to AB divided by CB. Tan 45 degree is 1. 1 is equal to AB is h and CB is x, which means x is equal to h. This distance and the height of hill are equal. X is equal to h, which is taken as 2. Now, we have to find the distance of the two stones, which means we have to find x and x plus 1. Yes. So, here in place of h, we can substitute x. Substituting 2 in 1. We get x plus 1 is equal to root 3 into x. That is, therefore, we will be having 1 is equal to root 3x minus x, or 1 is equal to x is taken out as common, root 3 minus 1. Okay, x into root 3 minus 1 is equal to 1. Now, we have x is equal to 1 divided by root 3 minus 1. In this case, what you will do, you will take the conjugate of this complex conjugate and multiply with the numerator and denominator. Here, root 3 minus 1, the complex conjugate will be root 3 plus 1. So, x is equal to 1 by root 3 minus 1 into root 3 plus 1 divided by root 3 plus 1. That is root 3 plus 1 divided by a minus b into a plus b, that is a square minus b square. Root 3 square is 3 minus 1 square is 1, which is equal to root 3 plus 1 divided by 3 minus 1 is 2. X is equal to 1 plus root 3 divided by 2. What is the value of root 3? 1.732 divided by 2, which is equal to 2.732 by 2, and that is equal to 1.366 meters. X is equal to 1.366 meters. So, we got the distance of the first stone from the foot of hill equal to 1.366 meters. Then what is the second distance? dB. Distance of the second stone from the foot of hill will be equal to x plus 1. X plus 1, the unit is kilometer, x plus 1 kilometer, 1.366 plus 1, which is 2.366 kilometers. Okay, 2.366 kilometers. The distance of the second stone is 2.366 kilometers. Clear? That's all for today. In today's class, we have discussed the application of trigonometry, heights and distances with examples, and solved many questions from exercise 22A and 22B. There are a few more questions which you can solve on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.